Hello, my name is Itai Rubin, and today I'm going to talk with you about liquid gold, recovered energy solutions from urban wastewater. When I moved to New York, I noticed the volume of waste in the city. We're literally drowning in waste. At the most basic level, people throw perfectly usable furniture and electronics on the street every day. We consume water, electricity, plastic, and metals without thinking about what happened the minute after we finish using them, or their potential for reuse. City dwellers create a lot of waste and consume energy. Cities can recover some of that energy from waste. I'm going to present 3 sources of urban waste, including 1. Food waste processing plant, 2. Wastewater processing plant, and 3. Wastewater from drains in buildings. To remain sustainable, cities must address the way they process waste, and to find ways to recover energy hidden in the waste. First, I'm going to explain how we can recover energy from food waste. In the US, 126 billion pounds of food are sent to the landfills, which include 52 billion pounds from manufacturers, grocery stores, and restaurants, and 54 billion pounds from home. An additional 20 billion pounds fresh produce are discarded on farms or left in the fields. The solution is in biogas processing plant, which convert organic materials into biogas using large anaerobic digestion tank. The byproducts of the process are renewable fuel and nutrient-rich soil fertilizers. In conclusion, converting food waste into energy through biogas system reduces fossil fuel usage and greenhouse gas emissions. It gives a second use to resources that were put into the food cycle. However, there are some limitations. Biodigesters are not always suitable for dense metropolitan areas. Fuel byproducts contain impurities, and digesters require room temperature for high efficiency. Next, I'm going to show how we can recapture energy at wastewater plants. High energy input are required to transport and treat water. Wastewater treatment plants consume 1 to 3% of the total electric energy output of a country. Wastewater is 99% pure water and 1% waste, primarily in the form of organic matter and nutrients. Sludge is the 1% solid waste remaining after refining the water. Scum is a floating material on the surface of the wastewater, typically fats, which can clog wastewater treatment systems. Sludge processed in the water treatment plant can produce energy used to run the plant, and can even reduce energy consumption to net zero. How is this achieved? Sludge from wastewater is equivalent to food waste, and is processed the same way. Beneficial byproducts of wastewater processing include 1. Heat released from sludge to produce hot water, steam, or hot air. 2. Methane gas from sludge which is consumed as fuel instead of being released into the atmosphere. 3. Water from the process is suitable for crop irrigation. And 4. The collected scum can be added to the mixture in the biodigester to improve performance. In conclusion, water treatment plants are large consumers of electricity, but by exploiting the byproducts from the wastewater treatment, for example, reusing the gas, solids, fat, water, heat, these plants can be net zero energy consumers or even earn revenues by creating and selling excess electricity. Finally, I will explain how energy can be recovered from wastewater in buildings. Urban water distribution systems require enormous amounts of energy to deliver and heat water for use in homes and offices. That energy literally goes down the drain once it's used. How can we capture and reuse this wasted energy? 1. We can use heat exchangers to draw the heat from the wastewater. 2. We can also use the kinetic energy from wastewater flowing down the drains and pipes. A heat exchanger is a system used to transfer heat between two fluids, which are typically separated by a barrier to prevent mixing. The heat exchanger can be installed on the drain line to draw heat from the warmed wastewater, for example, from showers, dishwashers, and washing machines. The warmed wastewater raises the temperature of the cold water passing through the heat exchangers on the way to the boilers. As a result, less energy is needed to heat the water in the boiler. The second solution uses an electrical turbine to convert flowing water to electricity. The turbine harnesses kinetic energy from water flowing down flush toilets or showers drains. In high-rise building, energy is needed to elevate water from the ground level to the floor above. Kinetic energy from every flush or shower we take can be retrieved to move this water throughout the building. Imagine a 100-meter building. One person uses 14,000 liters of water per year to flush the toilet, which requires 14 million joules of energy to lift the water to the roof tank. Recapturing part of this energy from flushed toilet water reduces the additional energy needed to pump water to the roof. Through these examples, we see that recapturing even a portion of the building waste energy using heat exchanger or turbines can significantly offset the energy needs of a building. In conclusion, we know that sustainable materials management is important in cities. It should be based on reducing the energy used and recovering energy from waste. Cities are starting to recognize the value of utilizing wastewater for energy. Finally, new technologies will continue to emerge to capture this valuable energy hidden in our waste. Thank you very much for your interest in this topic.